What if the obvious judgments your brain makes right now, in this very moment, are impossible for a computer to replicate? What if the simple act of retrieving something from a room is an unsolvable mystery for AI? In 1969, AI researchers John McCarthy and Patrick Hayes formulated a fundamental problem in artificial intelligence. Later, philosopher Daniel Dennett illustrated it vividly through a thought experiment. A robot retrieves a battery from a room. Just that, a simple task. But what happens to the bomb? What about the color of the walls? The weather outside the room? How does it distinguish relevant information from irrelevant information? This is the fundamental mystery of AI and common sense. The frame problem. By the time you finish this video, the meaning of the miracle your brain performs every second will look completely different. Chapter 1. The Robot's Dilemma. Dennett's thought experiment is simple. Give robot R1 an instruction. Retrieve the battery from the room. But inside the room, there's a time bomb. The battery is on a wagon. The bomb is also on that wagon. R1 retrieved the battery as instructed, but it also brought out the bomb. Result: explosion. Why did the robot fail? The researchers created R1D1. This robot was programmed to consider the side effects of actions. Retrieving the battery moves the bomb. This is a side effect. But R1D1 didn't move. The calculation never finished. Because R1D1 tried to calculate all side effects. Unless you explicitly specify what changes and what doesn't, the candidates for reasoning explode exponentially. This is the essence of the frame problem. And here's where a crucial question emerges. Why can humans do this? We instantly distinguish relevant information from irrelevant information. How? This is why common sense reasoning tends to break down with naive computation. But the problem runs deeper. So let's explore what human cognition is actually doing. Chapter 2. The Miracle Called Common Sense. According to one famous estimate, the human brain receives over 10 million bits of sensory information per second, yet we're consciously aware of only a few dozen bits. In other words, the brain unconsciously discards over 99% of information. How? From the late 1970s through the 1990s, cognitive scientists found an answer. The movement emphasizing the interaction between body and environment, embodied cognition, became systematized. Human cognition emerges from the interaction between body and environment. The brain is not an isolated computational machine. The brain is connected to the world through the body. This is the symbol grounding problem, proposed by cognitive scientist Stephen Harnad in 1990. AI knows the word apple, but the tactile sensation, the aroma, the taste, the weight. The grounding of meaning through these experiences remains a separate problem. In other words, common sense is born from bodily experience. A body that feels gravity. Hands that grasp objects. Eyes that see the world. These enable the judgment of relevance. And here's what makes this fascinating. In the mid-2010s, deep learning emerged. AI surpassed human discriminative ability in specific image recognition tasks. Yet common sense reasoning remained difficult. Recently, research has advanced in combining actions and tool manipulation with language models, making them behave as simplified world models. Even without embodiment, the ability to interact with external environments may develop capabilities approaching common sense. Consider this for a moment. If common sense is hard to explain through simple exhaustive computation, what does intelligence mean? The judgments we consider obvious are understood as efficient processing that combines body, environment, and learning. This is not a limitation of AI. This is the marvel of human cognition. So what does this discovery teach us? Let's look at the broader picture. Chapter 3. Redefining Intelligence. In the 2020s, the situation began to change. Large language models. Large-scale models with different purposes emerged, generative models like GPT and representation learning models like BERT. These learned patterns resembling common sense from vast amounts of text. On recent benchmark tests, they sometimes achieve human-level scores. but in responding to unknown situations, they still fall short of biological brains. AI extracts statistical patterns from massive data, trillions of words written by humans. Within them, something resembling common sense is hidden. Apples fall. Water is wet. People sleep. But this differs from human common sense. Humans acquire common sense by living in the world. Traditional I learned mainly from text, but recently signals closer to experience, images, audio, tool manipulation are being integrated. Philosopher John Searle presented the Chinese room in his 1980 paper, Minds, Brains, and Programs. The person in the room doesn't understand Chinese, but they manipulate symbols according to rules. From the outside, it appears they understand. But do they truly understand? This applies to AI's common sense as well. AI manipulates patterns of language. But does it understand meaning? And here's where the deepest question emerges. In fact, Meta's AI research chief Yann LeCun argues that text learning alone cannot reach physical common sense, advocating the necessity of new, quote, world models. If human common sense is based on bodily experience, can AI without a body possess true common sense? Or do multiple forms of common sense exist? This is a question that demands we redefine intelligence. Is intelligence computation, or is it experience? I don't have the answer. But this question touches the essence of what it means to think. The frame problem remains unsolved. But what this problem has taught us is the extraordinary complexity of human cognition. Every second, we unconsciously perform miracles, and we face new questions. So let's organize what this exploration has revealed. Chapter 4: The World Revealed. Now, today we've deeply explored the frame problem and common sense reasoning. What we've witnessed is the extraordinary capacity of human cognition. From vast sensory information, selecting only a small amount of conscious information, instantly distinguishing relevant information from irrelevant information. This is hard to explain through simple, exhaustive computation. It's efficient processing that combines body, environment, and learning. Let me share the insights gained from today's exploration. First, common sense is not merely an accumulation of data. Common sense is tacit knowledge born from interaction with the world. What the frame problem revealed is this fact: unless you explicitly specify what changes and what doesn't, reasoning candidates explode. Humans solve this problem through experience, not simple computation. Second, what the theory of embodiment, systematized from the late 1970s through the 1990s, made clear is that cognition emerges from the interaction between body and environment. The brain is not an isolated computational machine. A body that feels gravity, hands that grasp objects, eyes that see the world. These shape our common sense. Third, the emergence of large language models opened new paths for AI to acquire common sense. On benchmarks, they sometimes show human-level scores. But as Yann LeCun points out, text alone may not reach physical common sense. AI's evolution raises fundamental questions. What is intelligence? What is understanding? What these insights reveal is the deep mystery of human cognition. The judgments we consider obvious may be the most complex processing in the universe. Confronting the frame problem, I feel profound humility. Our brains perform miracles every second. Unconsciously, automatically, perfectly. And we still don't understand how. AI's evolution is a mirror of human cognition. Where AI struggles illuminates humanity's true capabilities. This is an intellectual journey, a journey without answers. Finally, I want to ask you, if common sense breaks down with simple computation, how extraordinary are the obvious judgments your brain makes right now, in this very moment? And if AI acquires different forms of common sense, does that mean multiple forms of intelligence exist? These questions have no answers yet. But continuing to ask moves us forward. The mystery called common sense is light that illuminates the future of humans and AI. After finishing this video, when you return to daily life, try to be slightly aware. When retrieving something from a room, notice the complexity of judgments you make unconsciously. Your brain instantly filters countless pieces of information, deriving optimal actions. This is a capability no supercomputer can easily replicate. And when you interact with AI, consider the mechanisms behind its responses. Does AI understand common sense, or is it imitating it? This question may transform your view of intelligence. Share your insights in the comments. Your questions become the force that drives this channel forward. Thank you for accompanying me on this intellectual journey to the end. The frame problem is not just AI's problem. This is a philosophical exploration asking who we are. At Mindshift, we continue exploring these domains where science and philosophy intersect. If you're interested in this intellectual adventure, please subscribe and turn on notifications. Next time, I have questions prepared that will shake your worldview. Until next time.